Okay, starting with this guy, let's say that we know this is square, and because this is right across from it, this is also square. So let's say that the side length of this square is 5, and then I'm also going to give you one other measure. Let's say that this measure up here is 12. Let's go with centimeters. So take a couple minutes and figure out the surface area of this thing. Now again, just as a reminder, if I fold this all up and fold it around, what I get is what's called a prism because it has two bases. So this three-dimensional rectangular type thing. So go ahead and find the surface area of that. Okay, so to find the surface area of this thing, I'm sure a lot of you thought like, okay, if this is 5, because that's 5, then the area of that guy is 5 times 12 because it's a rectangle. 5 times 12 is 60, so this is 60, so this is 60, so this is 60, and then also we have the area of this square itself, which is 5 times 5, so 25, and then 25, and then we can just add them all up. And so we get an area of, 25 plus 25 plus 60 plus 60 plus 60 plus 60, which is not the most efficient way to do this. However, we get 50 plus 240, so 290 centimeters squared. We can do it. However, hopefully you guys tried to think about this a different way, because what you do have here is that this whole inside shape, like all of this, is just one big rectangle. So really, you don't have to find each one. You could just find the area of the big rectangle, which has a length of 12, and then a width, or a height, I guess, over here, of 5 plus 5 plus 5 plus 5, so 20. So to find the area of this stuff around, we could really just do 12 times 20. Where this number here is like, 12 times 20. Where this number here is really the height of the prism, because it's how tall it is from one base to the other. And this number right here, 20, is really the stuff around the bottom, so the perimeter of the base. Then we can add that to the area of the bases, and there are 2 of them. So rather than adding each one, we'll just do 2 times 25, where this is the area of the base. So in general, that is the formula that we want to use. So if I interpret this as finding the surface area of a prism, it will always be 2 times big B, which is going to stand for area of the base, plus H times P, where H is height of the prism and P is perimeter of the base. So we want to put that in our notes underneath our surface area for a prism. Now the next guy that we have is very similar because it also has 2 bases, and that's this shape, except its bases are circles. So I'm going to give you a little bit of different information now. We're going to say that the radius of the circle is 4 centimeters. And then I'm going to tell you that the height of the prism, so between the 2 bases, is 10 centimeters. So this one is the same as that one. The only difference is the base shape. So you should use our formula, surface area equals 2 times the area of the base plus the height times perimeter. So try doing this cylinder guy like that. Okay, so hopefully we got this. We want to do surface area equals 2 times the area of the base plus perimeter times height. And sorry, I just rewrote it that way because capital letters should go first in my head. So we're going to do 2 times the area of the base. Well, the base shape is a circle. So to find the area of that, we need to do pi r squared plus the perimeter of the base. Well, the perimeter of the base, since it's a circle, isn't really a perimeter anymore. It's circumference. So 2 pi r times the height. And then I should just be able to fill these numbers in. So 2 times pi r squared, where r is 4, so 4 squared, plus 2 times pi times r, which is 4, times the height, which is 10. So then if I simplify it, we're going to have 4 squared, which is 16, times 2 is 32 pi, plus over here we're going to have 40 times 2, so 80 pi. And then, because these are both in terms of pi, we can add them, so 112 pi centimeters squared. So hopefully we got that one. Okay, so slightly different now are the other 2 shapes that I had. And just because we're on circles, let's start with the circle looking one. So this guy is different because it only has 1 circle. This has 2 circles. So that's why we had 2 times the area of the base. So this one's going to be a little bit different. But I'm going to give you some similar information. I'm going to tell you that the radius is 6 centimeters. And then I'm going to tell you, like, the length right here is 11 centimeters. So try and see if you can't figure out the area of that thing, the surface area. Okay, so maybe we thought, okay, I can find the area of the circle. That's pi r squared. So pi times 6 squared, so 36 pi is the area down here. Up here, there's lots of different ways we could do this. But if I'm looking at this thing, I'm thinking that this almost looks like a triangle, right, with a height of 11 here. So we could do 1/2 base times height, where the base, so 1/2 base times height, where the base is really this down here, which isn't really a measure that I know, except it is around the circle here, so it's really circumference. So you can do 1/2 times the base, which is really going to be circumference, so 2 pi r, which is 6, times the height, which is 11. So 1/2 of 2 is just 1, so we get 66 pi. Then we can add the 2 of those together to get a surface area of, let's see, 102 pi total. So I don't know if that's the way you did it, but that's the way we should do it. So really the formula that we're getting here for surface area is we're finding the area of just one base. So rather than 2 times area of the base, we just get base plus, then we did this area formula here, which my base was really circumference, or in general, perimeter. So plus 1/2 perimeter. And then technically, this is where it gets kind of weird, 11 is not a height. We could put height there, but 11 isn't really the height of this shape. If I construct this shape and like make it into a cone, which is what this thing is called, 11 isn't really the up and down height. If I put this thing together, 11 is the height along the slanted edge. So up and down height would have to go straight from the center straight down, and that's not really what I have here. So we made up this new letter, fancy L, and that stands for the slanted height, which is what we have here. The 11 is our slanted height because it's along the slanted edge. It would be a true height if it went from the top to the center of the circle on the bottom. So we want to make sure we get this in our notebooks, and then we're going to try one more with our last shape here, so this guy here. Let me give you a measurement. We're going to say, first of all, that this is a square on the bottom. Let's say that this side here is 7 units long or centimeters long. And I'm going to tell you the height of the triangle is 5 centimeters. So this is similar to the last one in so much as it has one base. So we want to do it the same way we did it here. Okay, so surface area equals area of the base. Well, the base is a square, so that's going to be 7 times 7, or 7 squared, plus half the perimeter of the base, which again, the base is a square, so 7 around is going to be 7 times 4, times the slanted height, which is right here, which is 5. So then we can just do our math. So 7 squared is 49, plus I can take half over here wherever I want. I'm going to take half of 4, that's 2. So then 14 times 5 is going to be 70, and so then 119 centimeters squared is my surface area here. Okay, so mostly what you're going to do tonight is just practice recognizing these shapes and naming them. So you can start your homework now. It should be super easy.